a couple more minutes and then start?
Yeah, sure. Sounds good.
Pradeep, maybe you want to start off?
Sure. Let me check. Just others can hear us, right? Just to confirm from students if they can hear us.
Yes, sir, you're audible.
Okay, great. Thank you. Just let me share my slides. Okay, let's get started. A warm welcome to anyone who's registered for the hackathon participants. A warm welcome from the DVCon India 2022 committee. I'm Pradeep Sala. I'm from Siemens EDA, and I'm currently the General Chair for DVCon India 2022. So a brief about DVCon, if you're not aware of it, basically it's a conference that's been here for a while. The focus of this conference is, for the industry and the academics to participate, contribute to new ideas, standards, methodology, and flows in RTL design and verification, providing a technical platform for both industry and academics. And it's also about managing your knowledge, right? How do you learn from the latest developments and trends, exchange the industry best practices? It's a good foot in the door for the academics who want to get into the industry as well. While we cater to the academics and engineers, we also make sure we give value to our sponsors and exhibitors to develop the markets and products and services. We have a lot of exhibits, stalls when we have DVCon live events. And it's also a building of your ecosystem and networking where you connect, share your thoughts, ideas, and experiences. So this is the platform, what DVCon or Design and Verification Conference enables. A brief history about DVCon. DVCon has always been sponsored by Accelera. And in the US, it's been for 30 plus years now. Initially, if you see, it started off with the VHDL International User Forum, International Forum in '88, and this is the International Verification Verilog Conference. And then, it became a combined conference in '97. And then eventually it became DVCon US in 2003. And then they wanted to expand in 2014. So that's how DVCon came into picture in Europe and India. And I'm proud to say that the first meeting that happened in the IEEE office in 2014, I have been part of it and been a part of DVCon journey since 2014. Then we expanded to DVCon China in 2017. And in 2018 is when, it was 30th year of DVCon US. And 2020, for obvious reasons, it was a virtual event, and in 2022, we are resuming to be an in-person event. And could you please go on mute, please? Then the other thing that we always try to do is every DVCon across the regions, we try to make it the look and feel the same. The number of days could vary, but the core of DVCon, which is the tutorials, panels, workshops, and the papers contributions, is what drives it. So it's an event for the participating or the delegates who participate in it. And I would like to congratulate all of you for being part of the first ever DVCon hackathon. We've never had done a hackathon in DVCon before. So, so this is going to be a truly thing in 2022. We can have one more bullet going here saying DVCon hackathon, and you can proudly say that you were the a participant in the first ever hackathon of DVCon. And this is just the beginning, and we would like to do a lot more things going forward in the future conferences. We talked about Accelera, sponsoring DVCon. So what is Accelera? Accelera Systems Initiative, that's what it's called. It's an industry body which provides a platform for the electronics industry to collaborate, to innovate, and deliver global standards, and overall improving the design and verification productivity for electronic products. So these are some of the standards that you see, which are currently the industry standards that was born out of Accelera. So here are the industries that support Accelera, part of Accelera membership. And then it's an annual thing, and they keep getting renewed every year. And this is how Accelera is, driven. It has a board of directors. Then there's a promotions committee. There's a technical committee and administration. So under the technical committee is the, you see that laundry list of standards and specifications that's out there. Some are obvious reasons are dormant because there's not much traction there. But active work is going on in all the other groups that you see. And Accelera is closely supported or works with IEEE. Some of the standards that you see here, once it becomes global and there's a lot of adoption after Accelera, then it goes on to become an IEEE working group, and it becomes an IEEE standard, just like how VHDL and Verilog and UPF and UVM are. It was all started off with Accelera, and now they are all an IEEE standard. Again, these are the current standards and supplement material that you could go to Accelera and then download all of these standards. Again, a strong partnership with IEEE and all of, we get, if you're a member of IEEE or Accelera, you get to access some of these specs or vice versa. And before we would like to, a big thank you to our global sponsors. These are our Accelera global sponsors, Cadence, Siemens, and Synopsys, which leads me to thank ADI, Analog Devices in India, because they are the hackathon sponsor. Analog Devices One is the company that's making this hackathon happen. So big thank you to Analog Devices. And on that, Shreya, over to you.
Thanks, Pradeep. Am I audible?
Yeah.
Let me just share my screen. Is the screen visible?
Yes, this.
Hi, so my name is Shreya Dasgupta. I'm a senior DV engineer at Analog Devices, and I'm serving on the steering committee of DVCon India 2022. So I'll take this opportunity to speak about Analog Devices, this being the hackathon sponsor. So Analog Devices, as is very evident from the name itself, has a very rich history of analog. Our first device was a product called 101 op-amp, which came out in 1965. And further to that, Analog has developed expertise in converting real-world phenomena into actionable information and insight, balancing accuracy and performance. However, over the years, more than 50 years now, analog devices does not mean only analog anymore. And I'll be getting into that in the slide that comes up. But luckily for us, the autonomy that we talk of now and AI that we talk of, the most powerful sectors where transformations are happening, are at this intersection of digital and physical worlds that analog devices is leading technologist in. So be it cars that can sense or machines that can learn, everything is driven by sensing. If you look at the picture on the right, it just shows a quick snapshot of how initially starts off with sensing and measuring data, but then quickly goes on to signal processing to make sense of that data, remove errors from that data, and then further, if the way things are expanding, you want to get into a security where you can embed secure information into the data exactly where it's born, which is the point that you want to make it secure till the endpoint where the data travels, and then communicate it through very challenging media in certain cases, while also designing the entire system level power around the entire system. Now that I've given a sense of where analog devices plays in, I want to go specifically into one application, rather one business, which is the business unit that I'm involved in. This is the BMS, which is the battery monitoring systems we work on electric vehicles. And I want to show how analog devices is no longer just analog, but analog plus plus. This block on the right, on the left that you see is a very top-level representation of what happens in an electric vehicle. This a close approximation of this would be present in the electric vehicles that came out in 2017 or so, like the Tesla Model 3. These modules are modules that are embedded deep within the battery pack, where each module is sensing a bunch of cells, maybe 12 or 14 or 8 cells, depending on how many channels are there. And this is our BMS sensor, which is sensing each cell of that module. Now, these BMS sensors, depending on how many modules are there, these BMS sensors are tied into a daisy chain, which then communicates with the BMS microprocessor. So the value that you see on the dashboard, which tells you how much juice you have left in the vehicle and how many miles you'll be able to drive, is something that the BMS microprocessor calculates based on all the details and data that it gathers from all these sensors that are present at the nodes. So at this level, the BMS basically consists of the sensor, which and system. So what I want to say here is analog devices would be selling the sensor as well as assisting clients, customers on designing the system. However, now in 2022, what has happened is, along with the sensor, we've driven a networking chip into it, along with the network stack. So this sensor, which used to be outside with a lot of wiring, now sits at the battery module itself. So which means that at every module, there is one system, which includes the sensor and the transceiver. And this whole thing gets into a battery pack. And there's another transceiver which sits at the BMS microprocessor and senses all these modules through this wireless mesh that gets set up. So in this wireless BMS, what has become a part of the analog devices deliverable is not only the sensor now, but the transceiver, which is significant digital, the system, which is the design of this PCB that gets into the battery module, as well as the software, which is the network stack that sits on this side, as well as the processor side, the manager side, as well as the battery pack design, because since this is a wireless system, it is very sensitive to the materials that the pack is made out of. So this is how the business has expanded, and I'm very happy to say that this is a leading industry leading technology which has made itself onto the DMS Hummer EV, which came out earlier this year in 2022. So this slide was basically to tell you that analog devices is a lot more than just analog. Though our strength continues to remain in analog, there's a lot of digital signal processing and system design analytics that is going to drive systems based around all the data that we sense in various businesses, be it healthcare or automotive or 5G. That is our space now. The next thing that I wanted to cover is verification, which is the domain I belong to and one of the domains that this conference is built around. In verification, of course, I have faced a lot of questions from freshers about verification, and there is a misunderstanding in certain cases that verification is testing, and it's not. A verification engineer needs to have exactly the same set of skills that a designer needs to have, plus, in addition to that, skills related to methodologies that verification test benches are written around. So earlier, Pradeep showed all those standards like UVM, portable stimulus, sorry, that are Accelera standards. And UVM is one of the things that a lot of digital verification engineers need to know, in addition to the system Verilog that both the digital designer as well as the digital verification engineer works in. So verification for a full chip would be driven by both the design part of it, as in what is the content of the design in the chip, as well as the domain driven methodology. We leave the domain driven methodology aside for now because that is not something I want to get into. But on the design-driven methodology side, there is digital verification and analog verification. Now, based on the content of a chip, and if you have analog skills which are related to, understanding schematics and understanding specific, regulators and the parameters that you would measure performance of those analog blocks by, you could get into mixed signal verification, where you have to create RNN models of the blocks that you work on based on your understanding of the schematics, as well as then get into analog digital co-simulation, which is when you take the digital that the schematic works with and set up an environment where the digital simulator as well as the analog simulator work in tandem, handshaking with each other. The RNN models, of course, are something that that go on into the system level or the digital verification side, where the system then is able to use this model and see the interactions that would happen between the digital and that specific model. On the digital verification side, functional verification itself is huge. It's system Verilog, UVM, C sometimes at system level. Functional verification engineers need to not only understand the block that they're working on, but get into the use cases around that block. Typically, ideally speaking, a functional verification engineer would be working off the same spec that a digital designer works on and create a golden model as well as a stimulus test bench where he or she puts in architecture for being able to feed random stimulus into that design as well as the golden model, and then finally compare how the behavior of the design and the golden model meet or differ, and in that way figure out whether there are issues in the design with respect to the specs that they received, or even if there are no issues, then go on to close off the verification for signing off and saying that, yes, we are good to go. Functional verification, the kind of designs it happens on, rather digital verification, the kind of designs it happens on is huge. And with technologies becoming more and more expensive, it has become even more important, because earlier what used to happen is designers could just write a few simulations and send out a chip, and the mask cost would be just $10,000, maybe at 180 nm. But coming down to 28 nm, which is the most stable technology today, the cost is now $1.5 million for a mask cost. So if you're sending out something that is costing you $1.5 million, you better know that things work. And verification is something that is critical to sign off and say that, yes, we're good to go, we can tape this out. The colors here, just to explain with respect to those systems that I showed you earlier. This is the earlier system that we had, which was based on a module with a sensor attached to it. And the methodologies that the verification was driven with was functional verification, RNA modeling, analog, digital, COSIM, and safety, leaving that side out. So the orange ones were the ones that were applicable for just the BMS sensor. Now, with the wireless BMS system, of course, the digital content has grown. So as you would expect, many more methodologies under digital verification are being used. And in addition to that, of course, because it's wireless, security becomes important. The main thing that I wanted to say in this slide is that verification is a pillar of the design team, the engineering team, and the expanse of things and the stages of the project that the verification team is getting involved in is earlier in the project at architecture level, as well as later in the project where the chip is going out to production and supporting it through production. So yeah, so that was what I wanted to say. So that's it I had for today. We won't take any questions right now. If you have any questions, please stay on over after the problem statement has been given out, and I'll be happy to answer. Over to you, Dr. Mula and Dr. Vivek for the problem statement.
Yeah, so Vivek will be presenting.
Just sharing my screen. 1 second. Is the screen visible? I mean, is the presentation visible?
No, you need
Not
to share
yet.
screen.
Not yet. 1 second.
Not yet.
Yeah, one second. Is it visible now?
Yes.
Okay, great. Yeah. So good evening, everyone, and a very warm welcome to the first DVCon Hackathon. So I believe all of you must have, when you were registering, you must have already seen the problem, the title for this hackathon, which is Accelerating AI on FPGA, right? So this is basically Dr. Subramaniam Mula and myself, Vivek. We are from Indian Institute of Technology, Palakkad, and both of us are assistant professor. I am in computer science and engineering department, and Dr. Mula is from electrical engineering department. So we are basically trying to take care of this hackathon in a sense that we are just looking into what the problem statement and other aspect of it. So first, let me just give you the general information that this is a virtual hackathon with 2 stages. Okay, stage 1. Today we are going to give you the problem statement. We are going to discuss the problem statement, and later, a draft on it is going to be shared with you over email. Okay. The deadline for submission of stage 1 is 12th August 2022, and the results are going to be published on 26th August. Whoever is selected to stage 1, they are going to participate in stage 2, which is going to happen between 30th August and 31st August. It's a 48-hour hackathon, where we were going to give you the problem at the start of 30th August, and then probably you have to submit your solution by 31st August. Timing and all of the information we'll share you at a later point of time. There are going to be some mentoring sessions which will help you to maybe understand, because you all must be coming from very different background and different level of experience with AI and FPGA both. So there are going to be some mentoring session which may help you to, probably do some better thing with the solution that you are working on. The final result of the hackathon is going to be on 6th September. The team size is you can have maximum of 3 members. Okay, so this is the general information on the hackathon. Now let me now jump to the problem statement. I'm sure all of you must be very excited to learn about the problem statement. So here's the problem statement. So we believe, because now you're participating in this hackathon, you all are really excited about AI, which is really becoming pervasive. Okay, and you all want to have a high performance, right? So ultimately what we want is that we want you to build a AI model, a deep learning model, which can which you should be able to accelerate. And this model, whatever you are building, has to detect some hand gestures. So this is a
We just lost Dr. Vivek, right?
Yeah.
Yeah,
Is not visible, and even the voice also.
Yeah.
I think we lost him.
I think they lost the connectivity.
is it visible now? I mean, sorry, my screen
Yes.
is visible.
Yeah, not yet.
Yes.
Yeah,
Yes.
now it's visible.
Okay, good. So, so let me just maybe repeat the statement once again. So what we really want you to do is we want you to build a detection model, okay? And we want you to accelerate the same model on FPGA, okay? What we are giving you is a data set which consists of 18 hand gestures classes, okay? So this problem, I think, whenever you have started learning about AI, or when you are getting into deep learning, or CNN, DNN, whatever, this kind of a problem you must have already seen. This is quite a general problem. Okay, so we want you to again deal with the same problem, but now you must have a different mindset, and the mindset is going to be different because the goal here is to deploy your model on FPGA. You want to accelerate the computation using the FPGA. Okay, so these are the steps that you have to follow. Okay, first of all, you need to download the data set from the link which is given over there. Okay, then you can decide and choose any model which you want to which you think may work better, or you can try several models and then figure out which model can work better for this detection. The minimum accuracy that we're expecting is 90%. Okay, you may have a much better accuracy or you may have a much worse accuracy, but the qualifying accuracy is 90% only. Okay, you have to create a 2-minute video of yourself as a subject, and then in that video you have to display these 18 different gestures. So you can display several, just I mean, with your two hands, you can try to display multiple gestures together, or you can display one gesture one at a time. Whatever you want to do, you can do it. There is no constraint on that. And the thing is, the video should not be longer than 2 minutes. Okay, then once whatever the model that you have trained using the data set that we have provided, you have to use the same model and then apply your video with that and try to see if you can detect those gestures. Okay, then the solution that you are going to submit on the video, we should be able to, whenever you make a gesture, that gesture should be annotated on that. Okay, so this is one part. Then the second part here is that whatever your experience with FPGA is, okay, based on that, you have to write a report in which you need to describe what is your approach or methodology that you are going to use to deploy this model on FPGA for the inference purpose only. So we don't want you to train the model on FPGA. We just want you to do the inference part on FPGA. So you can think about how you are going to deploy it, what kind of optimizations you want to apply. One thing you need to remember is there is no restriction on the size of FPGA or the type of FPGA or whatever. Okay, we are not concerned about that at this point of time. Okay, at this point of time, we only want to understand what is your approach in general. Okay, this is going to help us to understand your experience with FPGA. Okay, you have to specify what kind of tools you are going to use, what are the different steps that you are going to take, what level of optimization you want to do. So you might want to think about optimization at the AI level. I mean, that the at the model level, or you want to do some optimization at the design level, where you want to decide on, okay, how much resources do I really want to use, what parts I can accelerate, what part I cannot accelerate, whatever. Okay, so we want a very detailed description from you for the sixth step, which has been which you can see on the slide. Okay, and let me again repeat, it's a very open-ended kind of a problem statement, so you can do whatever you want. Okay, the main thing is what we want to see is that how well you can deploy the model on FPGA. Okay, so that means when you select even the learning model, you might want to consider, whether this kind of a model can really be deployed easily, or I have to, apply several optimization or several compressions or whatever. Okay. So what you really have to submit, and few things that you have to remember is, one, that you have to carefully consider the trade-offs between accuracy, FPGA resource utilization, and performance. Okay, and particularly for 0.6, if you are trying to deploy, it's not compulsory that you do an actual deployment. Okay, you can just discuss about the process, and even that is good enough. But if you have resources with you at your institute, you can do the deployment, and then whatever the files you have generated, you must share those files with it should be well commented, so that we can understand what has happened. Okay, so as a submissions, what we really need is a detailed and systematic report describing all the above steps, model performance evaluation, and your inferences on that, the video file that you have created. Okay, the Python code which you have probably which you might have used for your model. Okay, and please make sure that you are putting all the necessary comments. And then if you have deployed it actually, then you share your design and implementation files. Otherwise, your process or methodology you must have already added in the report which you are submitting. Okay. So
Professor Vivek, just to add, the submission links will be primarily easy chair. Just for videos, we might give you a separate link. So submission details will be given. The links will be given separately. If not, you could still use the easy chair ones, just to clarify.
Sure. Sure. Thank you. Yeah. And so this is our evaluation criteria. 35% weightage has been given to the model which you select for the detection. It's training and testing. Then 25% we have given to the report. So you really have to work very hard on the report. Okay. 15% is for the video. Okay. There is no constraint on which kind of a video file you are making. We just want a video which should run. That's all. And then 25% is for the FPGA based acceleration approach. Okay, so if you are someone who has really good experience with FPGA, you can do the deployment. That's very good. You please share the details how you have done it, and share the relevant files. If you are someone who has not that much of experience, but you really want to try this hackathon, just tell what is the general approach, and we'll consider that as well. Okay, but more information you have, more experience you have, that will help us to decide the best teams which can really compete in the second stage. Okay, there are going to be some mentoring sessions, and also in between we may also share some other reference material which we may use to gain some more knowledge and get some more hands-on skills. But majorly, based on your current experience, you should try to solve at least the stage 1 part. Okay, so this is all about the problem statement, what you need to submit, and the evaluation criteria. So if you have any questions for us, you may please feel free to ask now. Otherwise, you can also email us, or I don't know if EasyChair has a forum where they can put some questions. Shreya, EasyChair has a forum for them to share something, or they can email us.
So I think Pradeep, I don't know, EasyChair, I'm not very sure. I'm not seeing any mails from EasyChair.
There's no forum option. It has to be emails.
Okay, sure. So you can just email us if you have any questions on that.
So there is a doubt somebody wants to ask.
Yes, please.
Yeah, so just one point to add. So take this stage 1 as an exercise, right? As a practice for the stage 2. Okay, so stage 2 will also be a similar problem, but more complex problem. Okay, so use this stage 1 as a practice for the stage 2. Okay. Yeah.
Dr. Vivekan Mulla.
Yeah.
One small question. I think we have 250 plus participants, that is as the teams. What will be the cutoff criteria for moving them to next stage?
That we are going to have a leaderboard, and that whatever that percentage we want to take in, that will
it's a relative competition. It's a relative competition, right? So we'll fix the number of entries for the second stage, and top whatever the percentage will be selected.
Yeah, probably we have to fix the number of competents in the second stage. Based on that, we can choose the top.
Correct.
Yes.
Okay.
Yes.
Oh, sir. Hello.
Yes, please go ahead.
Yeah. Testing the image in using the FPGA. For example, if you are implementing software, can I just take an image of the hand gesture and then convert it to binary file and then upload it to my program in software, and then so that it can detect and then display the output, like in case if I don't have an FPGA?
Yeah, of course, that's what you have to do. So you can probably use a Colab or something, right, to train your model, and then maybe from this
quarters.
Yes.
Yeah. Okay, sir. Thank you, sir. Like directly taking a live feed from the camera and then detecting.
No, it's up to you how you want to test it, but
okay.
Let me just clarify. Okay, there are two parts. Okay, the first part is where you have to train a model based on the data set what we have given to you, and then you have to add few more things to the same algorithm what you are developing, so that you can analyze a video. Okay, the video is what you have created. Okay, so the output has to be that in that video we should be able to see those annotated gestures. Okay, that's what we want to see as an output. Now the second part is the acceleration part. Okay, so there, whether you have FPGA or you don't have FPGA, you have to discuss your entire approach. Okay, if you have an FPGA access, you can try to deploy it, and whatever the relevant files are, you can share with us. It doesn't matter which FPGA you are using. Okay, which SoC you are using, it doesn't matter to us. We just want to see what what is your approach. Okay, the good thing, I mean, if you try to deploy it yourself, the good thing is going to give you a good hands-on before you go to stage 2. Okay, so whatever you can do, what maximum you can do in stage 1 for that is all good. Okay, so you can submit whatever the files you have generated. If you don't have an FPGA access, at least you have to give us an entire approach, entire detail, that according to you, what methodologies you are going to use, what tools you are going to use, and what kind of trade-offs that you are looking into based on your model that you have. Okay, so all those information you have to share with us.
So one more doubt, like regarding the video, you want us to detect the hand gestures of the trained model in Python, or you want to implement that in using Verilog or VSTL, and then you want to make a video of it working? I mean, for the first part of stage one.
So for the first part, you can simply use Python if you want. There's, I mean, you can use Python.
So we can use Python and train the model, and then using our live feed, we can test whether it is working properly or not.
Yes,
That's what you want to
yes,
submit as a video.
yes.
Okay, sir. Thank you.
We will be sharing an alias for you to write your questions to. For now, just hold on to your questions. We will be sharing an alias, so you don't have to write individually. You'll get an alias.
Yeah. Any other questions from any of the teams?
Sir, good evening, sir.
Yes.
Sir, if you are deploying it in Python, then how will be accelerating it in FPGA, sir? If we deploy it in FPGA only, it will be used.
So that is what you have to think. So if you don't see, again, it's an open-ended problem. If you want to do it at a different level, you can do it that way also. Okay. So the main thing, the problem statement is clear to you, right? You have to use a model, a learning model that can detect hand gestures, and then you have to accelerate that approach, that entire thing on FPGA. So the language is not a restriction here. Okay. So whichever level you want to deploy, you do a deployment. Okay. What we want to see is that your accuracies for the model is good. Okay. And you know how to do the deployment on FPGA.
Sir,
yes.
Is Python compulsory, or we can use any other language? Any other program?
Any other language. You can use any other programming language as well. There's no restriction.
Thank you, sir.
Yeah.
See, but ultimate objective is to deploy it on FPGA. Okay. So whichever. That's
yes,
the main
sir.
You should keep in mind.
Remember that part.
Yeah.
Sir.
Yes.
Do we have to only deploy the trained model to the FPGA, or do we also need to do the training?
You don't have to train the model on FPGA. Only the trained model needs to get deployed.
Only inference will be on the FPGA. Okay. Yeah.
Okay, so that the FPGA can take any image input and process and give us the required output.
Yes, exactly. Yeah.
Sir?
Yeah.
Sir, actually the deployment which we'll do on FPGA, do we need to present that also, or we just need to present our model and the report?
If you have access to FPGA and if you are doing a deployment, please share all the relevant files. If you don't have access to FPGA, but you're still using some tool to reach up to the endpoint before you burn it on the FPGA, so whatever whatever the simulation that you have done for that you can also share. In the report, please try to explain in detail what is your approach and methodologies that you are using to deploy it on the FPGA.
We are not looking for the FPGA bit file, just to be clear.
If you have done it, you can share it with us. If you have not done it, it's okay. So it's not the requirement. It's not mandatory. It's not mandatory.
Yes. It doesn't hold any points.
Yeah.
It's for our understanding. Yeah.
It's for our understanding only.
So there is no point on acceleration on FPGA. If we are able to deploy it without any acceleration on FPGA, that's also fine.
At this stage, yes.
Okay, sir.
Okay. All right. I think other questions, if you have, you can email us, and then we can probably keep replying to your questions. Is that okay with everyone? I think most relevant questions are already asked. So
yeah. It should be clear.
Yeah. Everything seems fine, probably.
Yeah. We'll share this. We'll share this PDF
one small
email.
One small suggestion.
Yeah.
Since we are not insisting on the scripting language, can we add along with Python any other language can also be used, or shall we remove that Python?
Yeah, I think we can put others. I mean, Python and other languages. I mean, anything is
any
fine.
other,
Sure, we can do that. We can modify.
That will encourage people with other language
sure.
knowledge.
Yes, sure, no problem with that.
Thank you.
Okay, thank you. So I think Shreya, it's over to you.
Thank you, Dr. Vivek. Thanks, Dr. Mula, for coming up with the problem statement and explaining it out. So we will send out mailers with the problem statement as well as set up an alias for you guys to interact with us. And in any case, as soon as that email for contact goes out, you can reach out to us for any questions or issues. I think we're good. Anything else, Pradeep?
No, I think we're all good.
Okay. Thanks, everyone. Good luck to you all. And I hope you find it enjoyable and keep interacting and let us know what how things are going.
Yeah. Okay. Yeah. Thank you, everyone.
Thank you all.
Yes.
Thanks.
Yeah.
Bye.
Bye.